So now in this video we're going to look at adding push button switches, momentary tactile push button switches to a NAND gate. So the integrated circuit that you see here is the part number, and mostly we're interested in the 740000. So 7400 series integrated circuit, and 00, that lets us know that it is a quad NAND gate, and there was 4 of them in this kit. That's what that 4 means. The part number tells us that this is a quad NAND gate, and so we have an input there, and an output, which we have this jumper going there to extend where the output goes because it's pretty crowded here. That's one NAND gate. Right below it, input, output, another NAND gate, and then we have to power it. So that's the ground pin right there, and we have the VCC pin up here, and so then we have input, output for 2 other NAND gates. They're all independent NAND gates, so you can wire one up and ignore the others. And so first, let's get to the load. We're going to use a LED, the power is on, to see when the output is high, so close to the power source voltage, and we'll plug that into there. So it'll either be close to the power source voltage or the ground voltage, the negative rail there, 0 volt reference point. And we're going to use a 1 kilo ohm resistor to connect the LED to the negative rail, and the power is already on. You can see that the LED is on, and also you can see that it is not very stable right now. We are going to improve that later on, but for now we have a high signal, and that is what is important because there's no high signal at the inputs. So we're going to take a couple mechanical switches, and I already have orange jumpers to help with the spacing, but we're going to put the top of this switch to the jumper there. And remember, with these push button switches, the top 2 pins are always connected. So now this is like one long row instead of a row there and a row there. It bridges that gap. Same with the bottom down here, it's bridging that gap, and it's separated top to bottom though. I have to close the switch for the positive rail to come down to that pin. And we're going to put another one right next to it. You can see there's an orange jumper right there. The main takeaway is that these 2 pins that are floating right now, they shoot straight across to the inputs right there. And so I'm going to take this jumper here and go down to where that switch is right there, and then go to the top pin of the integrated circuit there, pin number 1, the input there. Now we're going to do the same thing here, going to pin number 2 from the other switch that's connected directly to the positive rail. So these inputs, they let just a very tiny trickle of current go through them, so I feel okay putting them directly to the positive rails. But now the output is high right now, so it's a NAND gate. It's the opposite of an AND gate. An AND gate, the output is low until you press both switches. So right now the output is high. It's the opposite. If I press one switch or the other, it stays high, but I press them both and now it goes low. And so it's the opposite of an AND gate. An AND gate, the output's low even if you press one or the other, but you press them both, then it turns on. So high and high equals a high output. This is the opposite. You need a high and high to get a low output. Otherwise it's high under the other conditions. So now one thing you may notice, we get a lot of weird flickering from the LED, and that is because the outputs or the inputs are floating. So we want to take care of that. They're not getting solidly to a low state even though we're not giving it a high signal. So we're going to take 10 kilo ohm resistors and connect them. You already see we have an improvement, and connect them from the negative rail there to the inputs. So this will make sure that they stay low, negative, however you want to refer it, until we solidly push the button. So they're headed to the negative rail. There is, quite a bit of resistance, but that doesn't matter. The pins are not really taking any current or anything. They're looking at the voltage. So right now they really see that negative voltage, even though there's high resistance. When we press the switch, that really overpowers what these resistors are doing to the negative rail to give a full positive signal. And again, if we press them both, then the output goes low. But as you can see, it's a lot more stable than it was before when we were building it. So it's really important to have these pull down resistors. That's what they're known as. They pull the voltage down because they're going to the negative rail. If they were going to the positive rail in a different circuit, they would be pull up resistors. They would hold the voltage up till you give a strong low signal. But these are pull down resistors because they're pulling down the voltage at the pins till we give a high signal. So that's all there really is to it. Normally I've been building my circuits to the far right of this. There's 4 breadboards, but where I had this switch inserted down there, it was not connecting down here at all. And so be aware that these breadboards, they do wear out, and especially if you have something with pins, even these pins, they're not exactly like the jumpers. The jumpers do pretty well at keeping the integrity of the slots pretty well, but these other things, especially the trim pots, they have kind of weird shaped pins, and especially if it gets inserted the wrong direction or something, it might damage that spot. So be aware of that. That's one reason why I build particular things in particular areas, so that I'm kind of aware that the spot might get damaged there, and I don't want it to influence other components. But in any case, that's it for this video, and I'm just starting to do a little bit more with these integrated circuits, and so it's going to be basic stuff for a while, but hopefully I come up with really interesting things for people that have these laying around. They're semi-common, and not much material out there telling you how to use them. So hopefully you enjoyed this video. Thank you for watching. I will see you in the next one.